Going back to the Lubbock, yeah, just straight to the VOR, then Victor route to wherever was best.
Okay. Thank you.
So let's go back though to the Portland, Ontario, and use that one kind of as the example of like doing all the rest of the stuff. Okay. So Battleground J67, Lakeview J5, EHF Ziggy 6. Okay, so if you have that part of it done, you're basically all the way through your simplified at this point. So Jaden and I did this one over the weekend while we were, because I was up basically staying at his house. So we worked through this one. What was the simplified that we came up with? I want to say our simplified was like, I think it was 6.9 or 6.7.
Yeah,
6.7. So same ballpark as where you guys are at, 6.7. And I know if the route varied just a little bit, then that's going to make a little bit of a difference too. But
on that simplified, I know that you were saying like once you get your simplified, then you go back to your estimated and you do that in the middle. Is that the middle one? Is that the one you're putting on, or is it just the actual like
the one that you write, like in the little thing where it says simplified on the chart? Put the number you actually got.
That's what
on that, like the one that you got right off the chart, and before you would maybe adjust a little bit by meeting it in between, halfway in between the other and your initial.
Oh,
so
really?
Yeah,
Maybe
it's
go
not.
back and change that?
You don't need to go back and change those. No, like none of that stuff is even looked at on the final, like on the FAA practical flight plan, right? So the only reason you're doing that is just maybe adjusting kind of in your head to kind of know really the range that you're going to want to be in. I know a lot of you guys have asked me, like after, especially once we do the initial fuel and then we do the simplified fuel and then the final fuel, right? It's like, why do we do the fuel so much? Like why? So the only reason we do the initial fuel at all, the only reason is because we have to kind of have a rough idea of a ballpark figure of how much fuel we're going to need total in order to do our weight and balance. Because the problem is with the simplified, when we do the simplified, we have to know what our takeoff weight is, more or less, like in an idea, like a ballpark number for our takeoff weight. And unless we do the initial fuel, there's no way to come up with a takeoff weight at all. So that's really the only reason we're doing the initial one. Okay. The important ones really are the simplified and then the final, and how those two compare to each other at the end. Okay, that's really what you're wanting to look at. But the biggest reason we do the initial is just to get a ballpark idea of fuel, to do our weight and balance, because we have to do our weight and balance and figure out our takeoff weight in order to even start the simplified. Because the simplified, we have to have the takeoff weight, we got to figure out the ISA temperature at the departure airport at the origin. We have to figure out our whole average winds aloft, but we also have to figure out our cruising altitude. So the only way to figure out cruising altitude is knowing your takeoff weight and your ISA temperature. So that's why we do the initial one. And then the simplified, is the final part of that whole first part that you guys have been working on. And then from there, we run on with the next part. So
on the practical, will we get the wind loft numbers, or are we having to find those?
No, it'll be all just like this.
Okay.
Just like this. So
on your practical, after you finish it, do they sit down and go through and check all your numbers and basically do it all again, or he just sits and watches and yeah, looks like you did it right?
He looks at your fuel compared to his fuel. That's really all he's looking at. So the big factors are the total. He looks at his total distance, what yours is. Not that they have to be the same, but they got to be in the same ballpark area, right? He looks at his total fuel compared to your total fuel. He looks at the big things that he's going to look at are, did you apply whatever MEL restrictions were imposed? Did it need an alternate, and did you have one? Did the alternate you choose, was it okay as far as legality? That's kind of the stuff we're going to be looking at here forward. But it's more of like all of the legality parts of the release of the flight plan are going to be what's looked at. Was it legal? Like, was it a plan that wasn't even legal to go, but you didn't say anything like in the first 10 minutes or whatever that you were looking at it? Like, if those are going to be the real big things as far as the practical, like the FAA practical. So if you do, you get all the way through and you've got the flight plan done. As far as the actual flight plan, he's just looking at the estimated time en route, the total distance, the total fuel, and how it compares to his. And he is pretty liberal as far as you can be 1,000 pounds off on fuel, and that's considered in his range. So.
And we're doing all this without that vector.
Yeah. Yep. I know you guys keep cringing every time we bring that up, but I'm telling you.
So one of my concerns, I know that you can, make the Jefferson charts available offline, but like I've done that and still sometimes they don't load. So what if I get in there and I can't load like the information that I need?
Well, worst case scenario, you'll have a big binder with all of them in there.
Okay.
So even if you can't bring them up on your computer, you'll just have a binder with tabs. No, the wins aloft, all that stuff, he's going to give to you. Yeah, he just gives you a big printout. Yeah, you won't even look at any of that stuff online. He just hands you a packet with all the weather, the NOTAMs. That's all just going to be in a packet.
And the papers to like actually fill in, we bring those? Or
yeah, just bring a blank packet out of the ones that I give you. Just print one off and just bring that.
So really the only thing we'll even need to use like the computer for is those charts? Like everything else will be there on paper?
Yep. Yeah. And the charts, like I said, I have a binder that's just a binder that is like the Jefferson chart folder. It's just a binder that has all the airports. So you just go to whatever airport tab and then open it up, and there's all the same stuff.
We could really do the whole thing, just not even looking at it, the computer.
Just the flight computer calculator portion, right?
Yep. And if you have the WizWheel, you don't even need that.
And so like the charts that we have to look at to find, like the reference charts to plot this stuff, do we need to bring that too, or is that like in the binder that we can reference?
So the materials that are provided for you will be all of the charts that we are looking at on here.
Like the Jefferson ones? Or
the Jefferson and all of the performance charts. Okay. You'll have all of that stuff. And then, all of the takeoff, stab, trim, the performance cards, all of that stuff you'll have. So, yeah, there's nothing that won't be there. All of my stuff, the airway charts, and if you want to use my ruler thing, the measurement stuff, and then my other thing, you can, the thing that I figure out the fuel and the winds with. You can use that, but you'll be able to use your phone as long as you don't have your Wi-Fi and your data on. So, and then you can, if you bring a tablet, and you get into when I say like we're going to have an offline version, all I'm going to do is it'll just be like a jump drive that you can just put in and bring it up. So there would be no reason that those wouldn't come up on your computer because it's just going to be a straight file. So not like the Google. It wouldn't be like getting into the Google Drive. It would just be, even though if you wanted to, you could go into the Google Drive and you could just save those.
Yeah.
So there's no reason those shouldn't download right now, and just if you wanted to create a drive for it. So that's probably easier than using even my jump drive, but whatever. those should work, and you can make sure that works obviously beforehand. So from here, so we had 67 on our simplified fuel. So the next part of this that we jump into is starting to do all the actual flight plan legs. So what I do is I get, and when I'm doing this manually, like not on the computer, I normally just take one of my packets, like this one, I just draw on the back of this right here. So, if you have one blank, that's the easiest thing to do is just take one of those and flip it over, and that's exactly what I did here. So I just go through and start putting, this is not the one we're doing, but I go through and I just throw everything into it. So I'm going to bring up just a thing so we can start doing those calculations. Okay, so what we're looking for here is we need to figure out, first of all, like the very first step of this next process really is figuring out where our top of climb and our top of descent are, okay, because that's going to be the big determining factor on where you pick your other points as far as dividing up the route goes, okay? So just to make sure everybody's following at the exact same kind of point here, we're done with simplified, and now just doing first step of the next process, the process of doing all of the individual actual flight plan calculations. So I'm just getting out my scratch paper here, and I'm going to do my little drawing. Climb, en route, descent. As soon as it lets me. Okay, so just going to plug in some of the information that I already have, that you already had to figure out, that's going to help you going forward as well. So we're leaving in Portland there. Portland, by my calculations, was ISA plus 10. Okay, so what did you guys have as a takeoff weight on this flight?
It was 69,899.
So you had 69. Anybody have any much different?
349, or on the last three numbers, 69, 349.
69, 349. The one we had was like 67. We had 67. 67, like one, or
like 67, 440.
So we were like 67.5. So your total fuel was 12.9. Anybody else have it? There's Andy. No,
it's just 12.3.
12.3. And your total fuel?
11,750.
Okay.
So close.
Yeah. So this next part, we're just going to figure out. So we're looking first at our climb out section here. Okay, so we just need to know our ISA number. We need to know our takeoff weight. When you guys looked at your cruising altitude, what cruising altitude were you guys able to get up to?
It was 30. That paper.
39.
39.
I think it was 39 though, because we had to fly.
Yeah, because you have to fly at an even level, like
Yeah, so
like at a
even
to the nearest 1,000. And then it was
39.
going east, so it would be odd. So 39, that's what we got, was 39. So, okay, so we're going up to 39,000 feet, so we know that part of it. 390, okay. Let's go in and take a look at our charts here. So we're looking for climb out, ISA plus 10, and then we're going to plug in. We'll in your guys' case, we'll just use, because you guys both have 69,000, we'll just use that. Okay, or round it up to 70, I guess. So you want to round it up to the nearest 1,000 above what your takeoff weight is. Okay, that's ISA plus 5. So here's ISA plus 10, climb out. There's 70,000 feet, and there's, 70,000 pounds, and then there's 39,000 feet. Okay, so it's nice because we just have the one box to deal with here. Okay, so this one is giving us, in our top left-hand corner, it's giving us time, then it's giving us distance, and then it's giving us our total fuel and our true airspeed. So right here, it's taking us 27.5 minutes to climb out. That total fuel is 2,619 pounds. It's at 177.8 miles with a true airspeed of 387. So if you are on your flight plan calculation leg, bear with me while I bring up a blank one here. Hate when I have to restart my computer because then everything I had open is closed now. So.
What's your ROC again?
That's rate of climb, but that's not something we
Okay.
necessarily would use. Okay, let's bring this up. So technically, what we're starting this page is what we're doing, okay? So now that you're done with simplified, this is now the page that we're moving into here. So you can fill in the things that you need to fill in. We already know you can fill in the top stuff here if you want, if you didn't already. Anyway, you can fill all that out. You should already know all that. You should know your route. You can go ahead and put it in there. We put 39,000 feet. This flight did not need an alternate, correct? Nobody had any issues with NOTAMs or anything else, right? Pretty straightforward plan, pretty easy as far as weather and NOTAMs and things like that are concerned. So Portland to top of climb. Now we know our route. We didn't have a SID for this route, so we went direct battleground, and then on mine we did J67, and you guys you did J189. So you just put the jet route that that you're basically flying most of the climb on. So you basically are connecting immediately to that jet route after you take off. So for mine, it's the J67
So it should be 189.
Yeah. Okay. So going back to this. So we know that it's 177.8 miles in 27.5 minutes. So if you're, the nice thing about the climb and the descent is that it just gives you everything. You don't got to do any calculating. It just gives it to you, which is awesome. So you can just go ahead and write those numbers in if you want. The total distance is 177.8, and then that total time was, what was it again? 27.5. Okay, and then the total burn, 2,619. And then remember, on the climb and the descent, that's actually the total. That's both engines included in this. And then the true airspeed is 387. So 2619 is the total burn. Okay, and what did we say? What was you guys' takeoff weight? 69.
69899.
Okay. So you should have that just have already put in there. So you're just carrying over your takeoff weight into starting at the top there. As far as this other information goes, 387 was the true airspeed. The magnetic course, if I go back to Sky Vector, all I'm going to do when I look at this is once I get onto J67, I'm just really looking at the heading and see that 134 right there. The one thing that's kind of important to know, like on this part, as far as the climb and the descent, because we already have all of our fuel figured out, we're really just transferring information here. We're just kind of filling in the boxes. So even if you don't have, like, the calculation's already done. So having the exact correct heading right here is not a big deal, okay? It's just go and look and put like an idea of what direction it's heading from, for that you're flying the majority of this climb on. So it's when we start looking at the next ones, the en route part, that we need to make sure that we're correct on our headings and stuff like that, because it's going to make a difference on how it compares to the wind and stuff. But for the climb and the descent, because we're not factoring in wind, it doesn't really, we're just really putting something here to put it in here. That's pretty much it. We don't do the wind, so I usually just write in whatever ISA chart we're using, which is ISA plus 10. The magnetic heading is going to be the same because there is no wind. So magnetic course and magnetic heading will always be the same on climb and descent.
Can you say that again? Magnetic heading?
The magnetic heading and the magnetic course will always be the same for climb and descent because there's no wind. The only thing, so if you think about it, the only thing that makes your magnetic heading different than your magnetic course is just always wind. It's like you're heading this direction, and the only thing that's going to make you have to like tilt into, they call it crabbing, but like into a different direction would just be the wind blowing you around. So when it's windless, your actual heading is going to be your true heading. Your magnetic course and your magnetic heading will be the same, and your ground speed and your true airspeed will also always be the same. And that's kind of the question you were asking.
Yeah.
So you just transfer it over, 387. So these ones are always really easy to do. You can fly through these because the information is just given to us on the charts. So it's really just a matter of just throwing something in the boxes there. Put something that's semi-accurate, but you get those numbers from the charts. The only thing that you're kind of just throwing in there is that magnetic course is the only thing that's kind of like, make sure you're plus or minus 5 of what you're really heading. But
The last one we did, we didn't even put anything in there.
And if you don't necessarily have to. If you do, just kind of do what I just did. Just kind of get an idea of a rough heading for that leg. That's all. Then the only other thing here is go to your takeoff weight, minus your burn out of it, and then carry that down to the next leg there. So does anybody have that? 69,899 minus 2619?
67,280.
Okay. 67,280. That's going to be the start of the next one. So the only thing here is we're not going to move on to the en route part yet. We're going to now skip and go straight to the descent. Okay? The reason why we're doing it this way is because we need to know where our top of climb is and where our top of descent is. So if you want to go back to SkyVector really quick and figure out now where your top of climb is, it's going to be 177.8 miles along your route. From you start in Portland, start flying. Once you hit mile marker 177.8, that is your top of climb. So let's start looking at where that would be. If we bring up, you can bring up the nav log here. If you're doing this,
Yeah, how would you just do
if
this
you're
on
doing
top?
this on like a manual chart, I will show you. Let's actually do it that way. If you're having to add this up manually, you do it.
I tried using the nav log, and I tried using the smaller nav log, and it didn't work for me. I don't know what I was doing wrong, but I just had to
Well, let's use the map since that's start getting everybody comfortable. Okay. You have this, or even if you have any other. So this is H1 is the chart here. You kind of see how they're broken up right here. H1, H3. Anyway, so we're right here. That's battleground right there. We're taking off from Portland and then heading straight to battleground direct. Okay. So if you needed, so this one's not going to actually tell us that exact little mileage right there because it's going from Portland to battleground. So this might be the only thing that you would have to measure. So let's see. So 1 inch equals 20 nautical miles. So if you are having to just guesstimate, see now these, the nice thing about this little ruler is that it's already set to scale on these charts. So whatever it's saying right here is in mileage, it's going to be true on the chart. So if you do use this ruler, and this ruler will be there for you to use if you want it. So, show. So
even if you see like there's different like ends like this, you can just use this little tiny end if you wanted to. If you like bringing it down over here, and just put the 0 right at the center of the circle of Portland, and then you're going to the center of the VOR, so you're to just barely less than 4, so it's like maybe like 3.9. But between 3 and 4, right? So right there. Not too far.
Would you just say 4? Or can you get better round up?
So even if I use this side, that's a 5, so your 4's here. So it's still showing the same regardless of whether you use this or this, whatever side you're
Are they going to show us where the airport is on these maps? Because it would have taken me forever to find Little Portland. I should know my geography, but. That's awesome.
If you, when you're looking them up,
I mean, maybe things like that will stick out, maybe. I don't know.
Yeah,
Hopefully.
Just looking at.
To me, the VOR stick out more. Yeah.
Yeah, I mean, you can. What I would always do is I would just look at the chart that I needed. So if I knew I was using H1, and I could see it says Seattle and Portland right in here. So this is where it's going to be on the map. So I know when I roll out the map, it's going to be right in here. So I'm not looking all over the place.
Like, where's Portland? There's the ocean.
Yeah.
Oh, here's the mountains.
Yeah, or even if you see what you do recognize.
Wrong state.
So from there, so we're like 3 or 4 miles from the VOR to from the airport to the VOR, and then I was J67. Okay, and that was going from here all the way, so you can see there's a 215 box right there. That is going to go, if you look at it on the next one here, you can't see it. So now we use H3. I think this is H1 and H2. So let me get H3.
And does it just say kind of locations on it too, or how do you know that you need H1 or H3?
You can just look at that. Okay, so let's see. Sometimes it even helps not to put it open anything like this. If you were to put this onto it right here. So there's the plane, match up the plane. That should. So you got this VOR, so you got 215 in it. So anytime you see it in the box like this, that means it's between VOR to VOR. So if you see it, like little distances.
Like this one?
And what are we doing here?
So that's more like a circle, that means like direct to the next intersection. So
Okay, I know that, but what's our?
That's not a box, like these ones that are square. These are rectangular boxes. So if you see it written like this, if it has a box around it, that means it's between, that's the total distance between the 2 VORs before it and after it. Okay? So it's telling you the total distance from here to here. If you see the ones without the boxes, that's just telling you from the last intersection to the VOR.
Oh, cool.
So if you were, connecting to this J route here by an intersection, then you would know that intersection from there to there is only 82.
Okay.
But the ones with boxes mean it's from VOR to VOR.
Then what are these?
That is just, when you cross over that intersection, it should be telling you, like, if your reading on your thing should say to the next VOR, like 80 miles. It's basically telling you what you should be reading in your instrument. So it really doesn't apply too much to us, but.
Okay.
So.
I'm glad I didn't use that.
So if we're 177
How do we measure how far we are from it?
So the big thing is you don't necessarily need to like come and find exactly where your thing is. All you need to know is where is it at in relation to the map. Okay, so if you took off, so we know that we are
4 miles to get to
battleground, and then we have 215 takes us all the way to Lakeview. So now we're sitting at 219 miles, right? And our top of climb was 177.8. So just taking your 219 minus 177.8, how many miles is that? Yeah, somewhere.
But you'll route it as like 38 miles before Lakeview, remember?
Yeah.
Oh, okay. So did you want me to do that? What was it again?
Yeah, just so we know exactly how much it is.
Okay, what was it?
219 minus 177.8. Okay, so 41.2, if you did want to know where it's at, you can always just put that under the OR and go back. So it'll be 5, 10.
Look, it's our orphan.
25.
I got a little boy,
Oh,
and I don't think he speaks English, but he came to me and called my name.
someone speaks Spanish?
Yeah. Of course he speaks Spanish. Abajo?
Well,
Or down.
they're in a walk.
No, abajo means
Downstairs.
I heard a walk.
Oh, what's that?
I'm saying.
You're like, there's a little person.
And he's talking and he's like, ooh. And he just like reached, grabbed my hand. I'm like,
Yeah, there's like a church group that comes here on Tuesday nights.
I haven't seen you.
Probably just got lost, but they're usually downstairs in like the big.
Yeah, I can even
You're my mom now.
must not look like stranger.
I go home with you.
Stranger danger. So yeah, I mean, we're somewhere out in this area, but the big thing is here is that you don't necessarily need to know that exactly where it's at. All you need to really know is this, is that it's 41.2 miles before you get to Lakeview. So when you do your lakes, you just need to know like, okay, on my next one, I'm going to be this, I'm going to add 41.2 to it. That's all. So now the next one, so if we know that so far is 219, so let's say you're doing your total distance for your whole flight, okay? You've got the 4 plus the 215. Now from here, we went J5 to, we took J5 all the way to Chapter, but that's how we wrote it because we stayed on J5. So if this one, then we'll just look at what it connects to. So it's 182 from Lakeview to Mustang. And then the next one, see if you come down here and you look at J5 as it goes through the bottom here. So the next one, we have to get, we need H4, which is going to be just this, flip over. So J5 continues through and then we hit Chapter right there.
Also, you can't connect them that way, huh? You just flip them over.
Yeah, this one you just flip over.
So what was the distance?
You don't need to connect those ones.
244 to FMG, which hopefully was Mustang.
I kind of think like this, like when you're actually planning the route, it's going to be hard to be like, over and then back over.
Well, all you're looking for is J5. That's all we want to know. So the J5 comes down through here. Okay, and then the next.
Well, we were J67 until H3.
Oh, yeah. So yeah, you see J5 here going down through, and then you're just going to flip it over.
So at least I like what you're trying to figure out. But then I stopped to get a drink.
J5, following it, and you flip it over.
I don't leave now.
Yeah, no big deal.
So we're at 645 to that one.
645?
Yep.
Okay.
So far.
So 4, 215, and then 244. Actually, sorry. And then, oh, well, then add 183. Oh, not 183, sorry. 182. So 4, 215, 182, 244.
What was it, 244? Yep, 645.
Okay, 645, and that gets us to Shafter. Okay. Well, Shafter is the beginning of the ZB6, so we gotta actually pull up the star and then just add this up.
And that'll tell you the distance from the start to that. Yeah, they're not too hard.
Okay, so yeah, I mean, when you come back and start looking at this again, you're just seeing, you know, the same thing that we're looking at on the map here. Now, if we want to know that distance from Shafter continuing on in, now just bring up Ontario. And you're just going to bring up the Ziggy 6, or sorry, the Ziggy 5 on this one, but and then you just got to get your calculator out, start in Shafter right there, and now that 645 that you had there, Tyler. Did Tyler step down?
Yep,
Oh, 645. Okay. Now,
yeah, I was holding the sneeze in on it.
see, your distances are right here, so add 31. So add 31, 6.
Okay, so what are we doing?
Yeah. We're continuing, we're adding up the star now. So just take your 645 that you had.
Mm-hmm.
Now we're just adding up the rest of it. That's all we're doing.
Okay, so what do you have so far?
Okay, so just go, so add 31 to your 645. You're going to be the one adding it up for us. So 31, 6, 35.6, 30, 5.8, 5.1, 7.6, 3.5, 5.4. What does that give you so far?
775.
Okay. And now go, let's see, 11.6. So add 11.6 to it. Then what's that?
786.6.
Okay. So, I mean, it's getting up into the same. We had, Sky Vector was telling us 792. So there was probably a little bit of an adjustment between our Portland direct to the battleground VOR is probably where the difference is. But like I said, that's within an acceptable range, though. Like if you're coming up with 787, it said?
Yeah, 786.6.
And this was 792 is what Sky Vector says. So that's fine. That's not going to be much really of a difference at all. And there might actually be something where, actually, you know what? Sorry, I forgot this 5 right here. Add 5 to that.
Oh yeah, that's
791.6.
Okay. So even better. So it does take a little bit longer, obviously, to do it that way. But like I said, if it's, I mean, maybe 10 minutes more.
yeah.
That's all you're doing. What we just did is the extent to what you'll use that chart. That's it. So now if you have your distance, now you do all your other stuff. If you were just starting the plan and now doing your initial fuel, like you just created your route, now you take that 792.6, 791.6, and take that and use your 400 speed and start doing your math and get your initial fuel. So that's all that SkyVector would have just saved you. That's it. It's just that. So does that make everyone feel a little bit better?
Yeah.
A little bit. Because that's all that SkyVector does for us.
Really what I'm nervous about right now is if there's going to be MELs or takeoff alternate or any kind of alternate like that. That's like what I'm really stressed about.
As far as, and using SkyVector for it?
Practical. No, doing the practical and then my plane having MELs or the meeting alternates.
Mm-hmm. Well, that part we still haven't really even done in here, so you'll feel plenty comfortable with it. Trust me. By the time we're
Did you say we're
done
going today with some weather or something or anything?
Yeah, that was the idea. Is that we were gonna do. If we keep running through this one, I guess it depends on if you want me to keep going through this one or if you guys just want to start a new one. That's tough.
I would rather do something with MELs.
But I just know that some people are kind of wanting to just see like those next steps, and so that's kind of what I'm looking at here.
Can we maybe do, now that we have like the top of climb and top of descent, can we do just like one portion, one segment real quick first?
We still don't
just
have the
to run
top
me
of
through
descent yet, but
yeah, let's do at least one segment so I can remember the math, how to get
okay, that's
things.
fine. So we'll just do the first segment, which we don't need the top of descent for anyway. So.
Okay.
So you say we'll feel more comfortable with that over the next little bit. Are you going to be like posting the classes that you do with these other guys? Like, what if we can't make it? How are we going to?
Well, so even just like on the regular, like just like the next class, like if you didn't come to anything during the week, like the extra stuff that we're doing this week with these guys, then even just on Saturday. So the idea was today to start doing one and going through one, like put in the MELs. The only thing we're lacking is MELs and weather.
Yeah.
Okay. So it's not like it's a massive portion. It's just how do we do MELs and how do we calculate for the weather? Yeah. That's really the only question. You already know how to do the flight planning part of it. So it's really now just saying, okay, now I got a couple MELs. What am I going to have to take into consideration here?
And that usually just affects your minimum, right? Most of the time.
Yeah. So.
As part of weather, it'll just be like a segment up along the route, and you have to go around.
Yeah, you might have to route around something. So let's just start talking about MELs as an example, okay? So if I threw on an MEL into this flight plan that was, let's just say it was like one of the common MELs that you would see on like in in this class or on a final type scenario or on an exam in here or final FAA practical, I should say. Common one that he likes to use is like a pack, an AC pack being out. Okay. The only thing that does to us is makes us altitude restricted. So on the 700, if you have one pack out, what's the restriction? Does anybody remember?
31,000.
31,000 feet. So now you know, in fact, in a lot of cases, that MEL actually helps you. It actually makes the flight plan easier, in my opinion, because now you know that you're not going any higher than 31,000. You don't even have to go like figure out some of the other stuff because you know you're capped at 31,000. So as far as going and figuring out, you still got to go get your ISA numbers and things like that and figure out how long it's going to take to get to 31,000. But there's not going to be. The only thing you have to figure out is like, okay, well, if I'm capped at 31,000, but if I'm going west, then I'm really capped at 30,000 because I got to be at an even level. Okay.
So on the MELs, is there like MEL package?
I'll just show you. We'll just bring one up and I'll show you.
In the practical, will there be show all the MELs and what they are? Or do we have to know by heart what they are?
No, you don't have. No, you don't have to know anything MEL wise by heart. Like you'll have a book to look them up in, and in most cases he just gives you a print off with the MEL.
Oh, that's cool.
So no.
So we're having class on Saturday then?
Yes.
It's not actually the last class.
Well, this is the last class. This is supposed to be the last class, but we're gonna continue.
Yeah, that's why I was
So
asking because
are you gonna be out of town again? Okay.
not anymore.
Okay. So
I know, you should come breakfast so you can actually be there. You're always gone. And I brought cookies and you haven't even taken.
okay. So we're gonna look at the we're gonna go and look at the first leg now of this plan. So we figured out where the we got the top of climb figured out. So we know that it's 177.8 miles along the route. It's 41.2 miles before we get to Lakeview. Okay.
Yes.
So now the next segment here is just going to be TOC, top of climb, to, and when we did ours over the weekend, we just did it to Mustang, to the Mustang VOR. So let me just show you where that's at in relation here.
Which one finished just a little bit over 300 nautical miles?
Actually, it's under still. Because okay, so our top of climb was just before Lakeview, 41.2 miles, right? And then from Lakeview to Mustang is 182. So you're just 182 plus 41.2. So it shouldn't even be close to the 300, I don't think. 223.2.
And you just chose Mustang because it's easy to
I like
go
to choose
VORs if you can.
Yeah. And so like in this one, so now when you zoom back out and kind of look at the overall general direction here. Okay, so here's just a little bit. So here's Lakeview. Here's our top of climb, which is somewhere right here before it. But here's Lakeview, and then we are still kind of continuing on that same route. And that's Mustang right there.
Yeah.
So yeah, that works for sure. That's definitely generally the same heading. So yeah, it works good for us because we have a VOR to go off of. It's going to be all on J5. We know that it's going to be at 39,000 feet. So that part of it we know. The next part that we got to go in and figure out is our actual charts. Let's actually go back. We got to go look at our ISA and
Plus
flight
10,
levels.
right?
Well, that was for Portland.
Right?
So we haven't done it yet. We got to go average our winds.
Yeah. So
What was this one?
Week 7, day 2.
That's San Diego, Salt Lake that you're thinking of.
Oh, it's week 8.
It's week 8.
Day what?
Day 2.
Okay. Okay, so there's our winds aloft. So we know that our top of climb was just before Lakeview. And Mustang VOR, if you were to look on the map, Mustang is Reno. Okay, so Lakeview and Reno, obviously that's going to be pretty good for us to average. So we're going to be over here at 39,000 feet. So we're just going to average those two together for this lake. So 260 and 240 average 250, right? And then 13 knots and 62 knots. 37.5. Negative 47 and negative 47. Negative 47. Okay, 39,000 feet. What should ISA be at 39,000 feet?
78 minus 15 is 63.
Yep. It should be negative 63. Does anybody not feel good about how we are getting those numbers?
Minus 15.
Andrea, how about you? So,
I haven't been doing it.
okay, so all we're doing,
Since the other day. It's when it gets up to the high numbers that I have to think.
yeah, so you know ISA at sea level is 15 degrees.
That's when we get up to 39.
So so our quick math for doing it is going to be, I
You
will
just
bring
take
up
the first number, 39 times the 2, right?
Yep. So let's just go 39 times 2. It's going to be 78, and then just minus 15. Yep. 63. The only thing you got to remember there is just make it negative. Yep. So 39,000 feet should be negative 63 degrees. In our case, for this flight plan, we're at negative 47 is our average. So what's our deviation from ISA in this case?
15.
Minus, isn't it?
Well, it's because it's warmer.
But it's not getting more negative temperature, it's getting warmer.
So now remember, when you're dealing with negative temperatures, that the lower temperature is going to be the warmer one. So negative 63 is colder than negative 47. So like I was telling Jaden over the weekend, this is, people always don't feel dumb about it, but people always mess this up just because it's two negatives and you're dealing with negative temperatures. So just remember, negative 47 as compared to negative 63, you're warmer, so you're plus, ISA plus. Okay? So ISA.
When it's 16, would you do ISA plus 15 or would you do ISA plus 20?
Round up.
You round up.
Sweet.
So this is ISA plus 20 for 39,000 feet. Good for you? Okay. All right, so let's go back into the charts. Oh, and then we got our average speed. So 250. So if you want to put it on the scratch paper for segment 1 here, this is kind of where I put it down in here. This is en route segment 1. I'm just writing it out as top of climb to FMG. Then my average wind was 250 at, and we're just going to do 38. We're going to round up 37.5 up to 38. Okay, and we're at ISA plus 20. So now going back into the charts. Okay, so we're in the cruise charts here. Oh, sorry, yeah, those are still on. Okay. So now we're in cruise charts. ISA plus 5. So you're going to notice something on this one. Okay, ISA plus 20. And what was our takeoff weight? Yeah. 70, right? Or sorry, what's our weight going into this leg? It was 67 something. What did we have on that? 67.
Here's my original weight number,
67,280.
Okay. So we round that up to 68, but here's a problem.
Doesn't exist.
Doesn't exist.
Oh.
What that means for us, like I'll just describe what it means in real life. In real life, it means that it's too warm on that section. It's too warm to be flying at that altitude. So in real life, if this were a real flight, it would start out, it would be able to climb up to 39,000, but once they got on this segment, they would actually need to descend to 37. And then they could go back up if they want. Now, we're not going to do that in class, but that's what it would mean in this case, okay? Now, we don't get that advanced in this class. But just so you understand, I guess, what it's telling us. That's what it would mean, because there's no performance. When it's blank like this, it means that the aircraft is not capable of flying at that altitude and that temperature. But for our purposes, if you see a blank like this, just move it down and we'll just take the numbers from the next one below it. Okay?
What happens in your practical?
It won't.
Are you sure?
I'm positive.
Don't trick me.
I'm not tricking. The practical, he has 3 flight plans. And you're going to get one of those 3. I'll tell you the city pairs. That's not going to help you though.
No, don't do it. Don't do it. No, don't do it.
What are the city pairs?
They're all like.
One of them is Salt Lake, Portland. I don't even. Yeah, while you're writing them down, it's not gonna. It's not gonna.
Check it.
It's not gonna
We've
help.
already
I
done
promise.
Salt Lake, Portland.
Yeah. You guys have already done Salt Lake, Portland.
Professionals.
It's not gonna help though. Do you even know? So, but anyway. Yeah, that wouldn't even if it did happen. Let's just say that even if it did happen in your practical, like let's just say this was your practical, and that's what you got. You end up taking this box instead of that box. It's going to change your fuel by maybe 100 pounds total. So, in the long grand scheme, when you have 1,000 pounds to play with to be within of what his fuel is, the 100 on this one segment, it will be insignificant. So.
So what about if it doesn't have your ISA number? Like, I was in one, and I'm pretty sure I had like ISA +5, but there wasn't like a cruise chart for ISA +5.
Then
Or
you-
descent chart for ISA +5. I can't remember.
Yeah, on descent, it just skips. It goes ISA +10, ISA
Yeah.
+20. So you just go to whatever, you got to stay above it, but you got to go to the next one it has for you.
Okay.
Descent, though, and the reason why it does that is because descent numbers are insignificant as well. So like you saw how the descent is only like 200 pounds total. And so even if it went to ISA +5, it just, the numbers are so little change that it's not worth them issuing the chart for it. That's why they don't have it. Okay, so we're going to take these numbers right here. Remember, when you're looking at cruise charts, there's only 2 numbers on this that we care about. One is going to be the total engine, the pounds burned per engine per hour, which is this number, 1646. Now remember, if you're ever questioning what these things are, look right here. Pounds per hour per engine. We want that number, and we want this number. So the middle left and the bottom right, 1646 and 461. Those are the numbers that we want. We don't care about anything else in this box. It's just there to confuse you. So we have that 1646 number and 461.
So do we add the 1646 times 2? So we have 2 engines.
Yeah, you could. If you want to go ahead and do that, yeah. You can just make it, double it for now, and then it just means you won't do it later, but yeah. So yeah, you can.
Okay.
You eventually have to double it. So whether you do it now or whether you do it 3 steps from now makes no difference. That's all I'm saying. Okay. Everyone good on this? Just getting those 2 numbers, 1646 and 461. Okay. Let's now go back to this. Okay. And the only other thing that only other component that we need to figure out on this particular leg is what's our average heading for this leg. Okay. So we're starting out at the 41 miles before Lakeview. So we're still heading on this like 134 heading here that we left Battleground on. And now once we switch to head to Mustang, we're heading now 148. You see the 148 right off that VOR right there? So that's our new heading. And we're going to take that all the way, and it goes all the way down to Mustang. So really, we're between 134 and 148. So if you wanted to just even average those two together, that's fine. But most of this route is 148. So you have 41.2 miles of heading 134, and then you have 250 or 182 miles of heading 148. So most of it's 148, but any number you come up with between those two, honestly, is probably fine. However, if you just wanted to average them, I'm sure that's works just fine too. The only reason I was saying that more of it was 148, just in case you wanted to lean closer to 148, that's all. But if you said 144, that's fine.
So where would you put that in here? On this chart?
Your magnetic course.
Magnetic course.
Yeah, that's the average course that we're flying. So we can start filling in this. This true airspeed was that 461 that we got. I'm just going to go with 144 on the magnetic course. Okay, the winds, our average winds, which we are just going to grab from our little scratch paper that we already figured out, 250 at 38, and we're ISA plus 20. So 250 at 38. Okay, so now you need your trusty little apps. And if you want to see how I do it on this, I can show you.
I got one.
Oh yeah, you got the silver one, don't you?
I do. Yeah, I got one.
Okay, I'll just show you. I'll show you with yours.
Mine doesn't have as big numbers as yours.
Oh, yeah. It won't really make a difference, but.
I was just using it on the 100 usually, or trying to the other night.
Oh, okay. That works. Actually, it might actually be better for us just going up to the 200 because it gives a little bit more room.
Okay.
Yeah, pencil.
Yeah.
So what we're gonna do? So you just put that on the 200. And then we're looking at, we're going to the wind first. So we're going to adjust this to our wind direction, which is 250. So you're lining up true index with 250.
And then up by 30, 80.
Yeah. So then we're taking this and going up to 38.
20, 30. So right under 40.
Yep. Yeah, so you can just mark it.
Yes.
Okay.
Yeah.
So now we go to our heading, our magnetic course, 144. So we're just going to push this over to 144. I'm going to line that up with true index on 144.
Okay.
And now you take a look at where your wind is. So now remember, so this is like circling. It was here. Now it's circling to where it's right here. So now if you can imagine, this is the wind blowing. That's the plane.
Yeah.
That's the wind. So the wind is pushing you a little bit. Now to figure out the exact speed, you take this. So because this line's on the 200, you're moving this line up to the 200 now. Just slide it up until it's on 200.
Okay.
That's it. The difference between where the dot is and that and the 200 is how much tailwind that's giving you.
Like 9?
Yep, 8 or 9.
Oh. I could not grasp this.
Yeah, it's better to see in person. And these lines going over, so if you count the big lines here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, okay.
That's going to be your wind correction angle, which is that. So because it's mostly a crosswind, it's pushing the plane. So it's pushing the plane technically like this, because the wind, the nose of the plane is always going to want to go into the wind. So if you have the wind blowing like this, it's going to make the nose go like this. So the nose is going to be pointed 10 degrees to the right, although it's moving this way. So it'll kind of be like the nose of the plane is pointed like that, probably more like that, even though it's flying like this. with about an 8 or a 9 knot tailwind.
Okay.
So now let's see what they got. Oh yeah.
Yeah, this is what I've been.
So what'd you guys get on tailwind?
5. Like,
5? Was that from doing it on the app? Or
yeah, so, oh, you mean like the
True
wind angle or the heading? Wait, what are you asking me?
Yeah, so the difference between the true course and true headings are.
Yeah, it's
no,
5.
I want to know the ground speed.
Oh,
It's
470.
Because we didn't.
461 was
Yeah.
what we planned.
Oh, so you gotta put
So
461.
that's exactly what we got. So if you do it on this,
Which one is this one?
this
There
one,
will
you gotta,
be 6 different ones.
this is the one, so I think most of the iPhone users download this one, which is just E6B. It's custom interface.
Oh, okay.
So
On the other end. It's right here. That one?
So now this one we're gonna go into functions, plan lake, heading and ground speed.
Oh, okay.
So on this one, all you're gonna type in, so we're gonna type in our true course, which is the 144.
No.
Our true airspeed is 461. The direction is 250. And at 38. I'm just giving you, it'll plug in that rest of that stuff for you. So you true heading. But the biggest thing is that ground speed, 470 minus the 461, like it's telling you your tailplane table. So but that you can see how accurate even that was.
Yeah.
Because we got 8 or 9
Yeah.
essentially, which is exactly what it is. So.
Alright.
Okay, so we have a 9 knot tailwind. So it's making our magnetic heading be 149, and our ground speed is 470. Okay, so we have that figured out now. We're going 470 miles per hour across the ground. How far was this distance? Was this lake? It was like 223.2, I think.
Yes.
Okay. So if we have that total distance, let's just go ahead and write that in there.
223.2.
Yeah, 223.2. So now we have the two key things that we need to figure out everything else. Your ground speed and your distance. With those two things, it's going to allow us to now do our math on the rest of it. So if we need to go 223 miles and we're doing 470 miles per hour, how do we figure out how long that's going to take us?
Ground speed divided by distance?
Yeah, distance divided by ground speed. So 223.2 divided by 470.
0.4749.
Yeah, let's just call it 0.475. Okay, 0.475. So if you remember that, if you need to write that down, that's fine. Or if you put that in your little note on that lake, 0.475, that's going to be your little thing that you're going to use to do your calculation. That decimal is what you're using now to figure out the rest of your stuff. So are you wondering how we got to 0.475? Okay, your distance divided by your ground speed.
And why are you saving that number?
Because you need to know that's how much.
Oh, your total distance for the whole trip, or you're talking
No, just this leg. So we only care about this leg, but we want to know how much time it's going to take us. You got to figure out two different things. Because you have to figure out the conversion, basically, right? So if we take 223, we want to know how long it's going to take us to go 223 miles if we're doing 470 miles an hour.
The reason I was confused is because I thought that you were saying to to save that number for the rest of all the segments?
No,
too?
just this.
That's why I was like, wait a second.
No, yeah, it is only applicable to this segment.
That makes sense.
So you have, like, I have different notes for every segment. Like, that's, so you gotta, like, be careful not to, like, mix and match stuff for this segment that belongs to another segment or whatever. But so if you were just, keeping it, like, when I do it, like I'm showing on this, anything that's below this only applies to this. And then the next one that I do only applies to that one. But they're all going to be different numbers. So this one was the 0.475.
And then you times that by 60, right?
Yep. So you got that 0.475, and now you want to convert that to minutes. Just times it by 60, which is going to be 1 hour. So it's going to be 28.5 minutes. So now we've got our minutes. Now we just need to figure out fuel. So our pounds per engine per hour was 1646. If you already doubled it like Courtney did, right? What was your doubled up?
I didn't do it. You freaked me out.
1,292.
I'm just saying it doesn't matter when you do it. Like if you do it then just write it, so that you already have the number. But I just normally double it here because I'm already doing the math right here. That's the only reason. So 3292 is what we're burning per hour total for both engines. So all you're doing here now,
Just timesing that by you.
you need to get how much you're burning per minute. So just take this, and there's two ways you can do it at this point, okay? Two ways. Whichever way is easier, but going back to that 0.475 number, the easiest way is if you have that written down and memorized, then just take this and just go times 0.475. That'll give you your fuel. If you didn't write that down, then you're going to have to do the conversion again. And if you didn't, then your 3292 divided by 60 times how long you're flying. So 28.5. Same number. You just had to do an extra step. If you kept that 0.475, then it just eliminates the step on the next one. That's basically all that I was trying to allude to on that one. So 1563.7.
You don't round on your.
Yeah, I usually do. I just was thinking that. I was like, I'll just call it 1564. Then you just minus that from that weight, and then you move it down again. And does that help on that one?
Yeah, a lot. Thank you.
It's not actually on in here.
Is it not?
No.
My room was so cold right now.
It's
sweaty.
it's the next class.
I'm sweaty. You want my sweater? It's all my fabric.
It's all unlist,
You know what? I will
It
maybe
smells
I
salty.
said that. I did not get
Oh,
more.
sorry. It's for glistening. It's for glistening. You're good.
I need to smoke now. That was a lot.
Well, it's a good time for a break, but does that help?
Way
It's
better
making
now.
way more sense. Yeah,
Way
I
more.
feel like when we did it before, it was like we were doing it
I was so
slower.
confused before.
Now I know where to put all these different
Numbers.
all the different equations that I wrote out. I'm like, shoot, I don't remember where to plug those in at. But now I get it.
Okay. The easiest thing for me when I was going through it is I just make individual columns and keep my calculations separate, so that, because sometimes if you're just throwing up scratch paper wherever, just right here, I mean, you end up losing stuff. And I'm not saying that's what you're doing, but for
That's
me,
what I was doing.
like I have to be like I would write in the distance there, and then I would actually like draw a line so that I could only write, and then I just knew that everything inside that line was only for that. And then the next one I did the same thing. It's only for that, so that I'm not looking back or thinking back of other numbers or other calculations that don't apply, you know. So that might, you know, hopefully that'll help. But so then let's take a break, and then when we come back, we're going to start one fresh. It's going to be a tougher flight. Okay, so this one that we're going to do now is Salt Lake to Helena, okay? Everything you see here so far is as you normally are used to seeing it, okay? You're getting your weather packet. Boom. We're using aircraft N765, 62 adults, 5 kids, 94 bags. Okay, well, there's something now you haven't seen, MELs. We've got a couple of MELs. MEL 3441-1 and MEL 2411-1 alpha. Okay? And then now we've got our ETD of 2200C. Okay? But everything else, you know, so far looks familiar. The only thing, MELs. Okay? So, first time we're seeing MELs here. So, when you get MELs like this, the way it normally is going to look is I give you, so this isn't the drive that you guys are in, but this is the way it's going to look. Like this is the stuff that will be uploaded for that particular thing. All of this different stuff in here that you see is going to be, you know, here's the route packet here. Here's the MEL. Here's the other MEL. And then I put a couple of weather charts in here as well for you to help with, because these ones also have some weather in them. Okay? So this one has a mix. It's going to be MELs and weather. So the first thing, though, that I'm really looking at here is, okay, I saw those 2 MELs. Well, what are these MELs? You're going to see them just like this. You don't got to go like flip open your book and go find it. I just put it in here for you. Looks just like that. Okay? I just copy and paste it right in there for you to read it. Okay, so MEL 3441-1, weather radar system. You should be familiar with that MEL already. When you're looking at the MELs, the big things that you want to read are going to be the remarks and exceptions and then the operation procedure. That's what's going to show us your restrictions. So may be inoperative provided that the aircraft will not be flown along a route where thunderstorms or potentially hazardous weather exists under IFR or night VFR conditions. So now we are flying IFR. Everything we do in here is IFR. So that big one's right there under IFR. Okay, that applies to us. And then thunderstorms and potentially hazardous weather. We can't fly a route that goes into or near where that's occurring. Okay? And then sometimes, a lot of times this down here just repeats. The flight crew will ensure the aircraft will not be flown along a route where thunderstorms or potentially hazardous weather exists under IFR or night VFR conditions. Okay, so right off the top of the, right off the beginning here, I'm thinking, okay, I've got a pretty big restriction potentially. I haven't even looked at the weather, but I've got a restriction. If I've got thunderstorms and stuff, I'm going to have to route this so it totally avoids them. Okay, so that should be the only thing going on in your head so far. Let's take a look at the next MEL. 2411-1A. Integrated Drive Generator Systems, constant speed drives. Okay. This says one may be inoperative provided that the respective generator 1-2 switch is selected on. So that doesn't really apply. So a lot of the stuff that you read in here doesn't necessarily apply to the dispatcher. It's whatever it's a lot of it's what the pilot has to make sure of in the plane. So the respective IDG is disconnected. APU generator is operated continuously throughout the flight. Okay, so that should be a big right there. That one, if you remember when we were talking about fuel burns and things like that, there was one of the fuel burns we talked about that the APU burns 260 pounds of fuel per hour. Okay. Continuing on, operations are conducted at or below flight level 320. The next one is repairs are made within 100 engine hours. Okay, so that doesn't really matter to you, but this operations are conducted at or below flight level 320, and the APU generator is operated continuously throughout the flight. Those two should be the two that stand out to a dispatcher. The APU being on the entire flight means that you have to compensate for that fuel-wise once it's in flight. Okay, so that's going back to that number that we talked about back in systems when we were talking about the APU. The APU, one of the things that we brought up about the APU is that it burns, if it's operating, it burns 260 pounds of fuel per hour while it's on. Okay, so if we know that we have to operate the APU continuously for the entire flight, then we need to add in an extra 260 pounds of fuel per hour in order to compensate for that. And then obviously the other big one is that this is a flight level restricted flight, because this is telling us that we have to operate at flight level 320 or below. Okay, so now you've read through, so we're done reading through the MELs, and you've got three big takeaways. I've got to avoid thunderstorms. I'm flight level restricted to 32,000 feet, and I've got the APU on the entire flight, and that means that I'm going to burn an extra 260 pounds of fuel per hour. You probably don't remember the flight level, or sorry, not the flight level, but the 260 pounds. But now you do, and
Where would you, let's say this was on our practical, would we have known that?
Systems.
it would be from systems, but it's the reason I put it in on the flight plans like this is because I know that most people probably don't remember it from systems, and the reason I put it in here is because it's the only MEL that's going to do this. So now that if you start seeing it, I have you practice it now just in case, because now once you start seeing it, you will remember. Okay, so that's why it's actually in here, is because I want you to remember it. But that one you would just have to remember. You just need to remember that the APU burns 260 pounds per hour if it's on. If they're making you run it like this one.
60.
260.
Okay. So is it 260?
So 260 pounds per hour. So it's really easy to add in that fuel. All you got to, once you figure out your ETE, okay, it's 2 hours, so I'm going to put in 260 times 2, whatever. Just add it in.
Put that in your burn fuel.
Just put it in your burn fuel, yep. Okay, so that's really it. So now we know. So the flight level 320, we know that that's a restriction. That's not going to affect our route. It's just going to affect the flight level, right? And then the extra fuel for the APU, just add that in once we figure out how long this is going to be. And then the other thing is just that weather radar MEL, which is saying no thunderstorms or potentially hazardous weather. So that MEL is going to make us want to take a look at thunderstorms. Here's Salt Lake City. So here's Salt Lake. Here's Helena.
Better not go.
All of this in between is thunderstorms. Well, so this is we should start a discussion here, kind of whether, between us, if you were doing this in your practical, start kind of debating this in your head. Well, if I did fly this, how would I do it?
Go west. And then go way west.
Exactly. So it's not that you can't fly this one.
If you want to.
And that, as far as a pilot probably doesn't.
That's where my brain gets me in trouble.
Yeah. So yeah, and that's the thing is you'll learn, like, there's if it's legal, the dispatcher is going to send it. Okay, the biggest thing that you have to decipher between as a dispatcher is it legal or is it not legal? If it's legal, the dispatcher is always going to send the release. Always.
Can I ask a really stupid question?
Yep.
I should probably know this type of class, but is there like certain like criteria that we should know for sure if it is legal to go, to figure out if it is legal to go?
The only thing that's going to make it not legal to go is going to be landing minimums. Okay, like if your forecast doesn't even have your landing minimums, if it has less than your landing minimums.
Which, another stupid question, is based on the airport or our aircraft?
It's going to be based on the chart for the airport, but on that chart you do go to category C and you look up whatever the 700 is, whatever the landing minimums are. For the ILS, hopefully, if you have an ILS for that airport, whatever runway you're picking, then you figure out what are my lowest possible legal landing minimums, and then you compare that to your forecast. And if you don't have that in your forecast, you either need to delay until you would have it, or if you don't ever have it in your forecast, then it's flat out not legal to go at all. So that's one thing that would make it not legal. Two would be, let's say you have an MEL for no like the weather radar. Okay, let's say you have a weather radar MEL, and then you go and look at the first thing you look at weather-wise is going to be the weather where I'm at, right? At your takeoff point. So for your origin, let's say that METAR has thunderstorm right in it. So there's a thunderstorm occurring where you're at. Well, that right there is going to make it not legal. Just things like that. Now, this particular plan, you can kind of see, there's not really thunderstorms around Salt Lake. And Helena is also north of the thunderstorms. So, like, conceivably, if you could route out to the west here and skirt the outside of this and come back around and into Helena, then we're fine. And so that's technically what we do with this flight plan. We don't file it through thunderstorms because we can't. We have to stay away from them. And we just go around the backside and then into Helena basically from the west. Instead of, we want to normally just go like this, but this is a case where we're not going to, this is not going to be the most economical route possible. It's going to be very uneconomical. So, but because of the MEL, that's the only way it's going to happen. So now, as long as you can find a legal way to do it, then it's legal, if that makes sense.
So if we're like in the practical then and we run into something like this or whatever, would we tell him if it is, like say we can delay it and then it is legal to go, would we still let him know that it had problems or whatever?
Yeah.
Okay.
Yeah, the thing is about what the examiner always wants to see is he wants to know primarily what's going on in your head. So the best thing to always do with the examiner is even if it's a question where you're wondering if it's legal or not, like just always ask the question, because as long as, like in this case, like let's say you had a question like, well, is this one legal to go or not? Like, now you don't necessarily like know what the examiner, is thinking in this case. Like he's definitely thinking, well, if she plans the straight route, like the most economical route, it's not legal. Okay? It's basically, so the dispatcher in this case is trying to figure out a way for it to be legal. Okay? Which a dispatcher, we do that every day. We figure out ways for flights to be legal. And we'll file them as such in order for it to maintain the legality. Now, some flights it's not possible, like your origin weather, like if your origin is below even takeoff minimums or something like that, then you just simply can't depart. You have to either just flat out delay the flight or cancel the flight or whatever. So the thing is you always need to ask the questions. Like you can go up, like in this case, if I were just being safe, I would go up to the examiner and I would say, I've got an MEL that says I can't fly, near in or around hazardous weather and thunderstorms. This route, I've got thunderstorms all over Idaho, Montana, Wyoming. I was like, so we can't fly. The only thing I would just basically say, it looks like the only thing we can do is go clear out to the west and route around it, or we can't go. You just throw the question to him, because he wants the question asked to him, basically, almost as if he's the decision maker. Okay? And so now remember, you are asking him the question. It's kind of like, the ones we were talking about a couple of weeks ago or last week, where we were saying, well, if it's not legal, then we just don't have to do the flight plan. Now, you have to know that the examiner, in some way, shape, or form, is still going to have you do the flight plan. That's the goal, right? So you know that there is a way. You just have to have him tell you the way sometimes. And so you give him the decision to say, we either need to delay until we can go straight on the route that we would normally want to fly, which we would need to delay to wait for all that weather to move away and out of the area or go away, right? So we either need to delay and do that, or we can depart now, but we would have to go clear out around to the west and then back into Helena. And you just give him those two options, and then he'll tell you what he wants you to do. He'll say, okay, let's say we delayed it 4 hours, and then he might even give you a new picture. Okay, well, we've waited now. Here's the new radar map, and then he'll give you one, and maybe it's all now way to the east, and now you can do that route. You just never know what he has in mind. Okay. So you just ask him, okay, I can do it this way now, or we can do it this way and delay. And then he'll say, okay, just go ahead and do it to the west or whatever. So in this case, we'll just say, we're going to depart now. We want that on-time, performance. So even though our arrival time is going to be way past, we're going to do that, and we're going to build a route that goes out to the west and around to Helena. So keeping the flight legal and everything else, that's kind of what we're trying to figure out what we need to do. And that's, in this case, that's what we're going to do, is we're just going to veer around out to the west and build a route for this. So there's another thing here. This is this next little chart that's in here is what's called it's called a Tcf chart. And basically what it is it's a weather product that tells us where thunderstorms are likely to be occurring. So this is one of the weather charts we looked at back in the weather, 8 weeks ago now. This is one of the most helpful products that we use as dispatchers, is looking at this chart. And this kind of, what this does is it gives us an idea at certain increments, like 4 hours from now, where are the thunderstorms likely to be? And that's kind of what this is saying. You can also look at another version that's like 6 hours from now, and then another one that's 8 hours from now, just to kind of see where they're at. So this is the chart that is basically 4 hours out, which is the minimum on the TCF chart. So in 4 hours, this is where it looks like we would be having thunderstorm problems. So what we're looking, because this is like a future view of what thunderstorms might be, it's not the current view. We already looked at the current view, right? And the current view was way worse. It was like all over here, right? So this is what it's expected to look like in 4 hours, though. And what does this help us do? The only thing that this is really helping us with is saying that, I know that the flight is not going to depart for probably 2 hours after I send the release. Like at least 90 minutes to 2 hours after I send the release is when it leaves. And then it takes a while to fly, obviously, maybe an hour or two to fly up to Helena. Okay, so now we are legitimately 4 hours from now is really pretty much when it's going to arrive, maybe, So I want to make sure that there's not one of these big red boxes right over now where Helena is. So that's kind of what this is helping us to do. Is like, okay, well, I'm looking at the current picture, and it looks like I can go around the west, and thunderstorms aren't currently in Helena, that we already saw that. It is just south of Helena, but not in Helena. So as long as we can go around and build a creative route, we can still legally fly this flight. okay, this one's helping me with like, okay, but what if later the thunderstorms now develop over Helena? What, and this is telling us that it's not likely to, it's likely, if anything, to shrink than it is to get bigger. So this is kind of helping us say, okay, so this is saying that it's probably supposed to be even better later. So if this was like, now, like, let's say this box, moved up to where it looked like it was going to move north over Helena, then we would reconsider. So, like I say, all of these ones, just so you guys know, every flight plan you guys see from here on out is going to be tougher than you're going to see on the practical. Just so you guys know. Just in case you're wondering if this is logically something you could get, it's not. You're not going to get this. Okay.
So Adam, what if you don't have that MEL that you can't fly through thunderstorms? Then what would you do with that weather?
Take it over.
Boom.
Just go straight through it. Okay.
Mow it over. No, that.
Like,
The consideration that you start looking at with that is this. Okay, you start looking. Okay, well, how bad is this? Like, you start looking at how high they are. Okay, so this one is at 30,000 feet. This one is at 35,000, 40,000. So you start comparing it to like, okay, well, if I'm not altitude restricted, now, if we just took out just simply the weather radar MEL, we still have that other one that's limiting us to 32,000 feet. Okay, so you start flying through this. We normally would go, if we can go over stuff, we'll go over it normally. Like if it's, let's say it's 35,000 and we're filed at 39, we'll just go right over the top of it, no big deal. But, you might run into a problem with this one that's 40,000 and reporting hail, or 45,000 here. But it also largely depends on how scattered the thunderstorms are. When we look at it on this map, it looks like it's all over the place. But if you were like flying through this, these gaps like right here, and most of this green stuff is just light rain. It's really the stuff that's bad is like the yellow and the red, which is pretty small. Like we fly through this green stuff all day long. It's the yellows and the reds that are going to be the more severe parts. So a lot of times the green will kind of confuse you a little bit, but just remember, green is just simply light rain. It's not anything hazardous like the MAL says. The hazardous is going to be your yellow and red areas. So if you were to able to just get rid of the green, this picture would totally change. Okay? And then on top of that, you start looking, okay, well, there's some over here, there's some over here. This gap in between the yellow right here, that gap right there is 100 miles. You're talking of like a needle, I mean, it looks different when you're looking at it like on the maps because you see this huge plain that's like the size of the entire state, and it's not proportionate to what it really is, obviously, and you see it going through this weather. It's like this thing has, 100 miles to fit through it. It's easily going to fit through it. So when it's really scattered, we don't have any problem. We just go straight up, and we just, they might have to veer off a little bit to the right in order to go around one. But thunderstorms in general are usually not bigger than 15, 20 miles. Sometimes you get a huge line of thunderstorms that, those don't normally happen in the mountains, but they'll happen out in the plains, like where you have a big line like that goes all the way, and it's just one solid line of yellow and red. Those ones you can't go through. Those ones you do have to route, clear either around or the bottom, the top, and you'll see that stuff. But in this case, scattered thunderstorms, they just pick their way through it. They just fly through it and in between.
Still file it straight though?
Yeah, you would file this on the canned route. The only thing that you would maybe do in this case is you would add some contingency fuel in case they need to vector around thunderstorms. And that's it. So if they're, what you see right now is great. Okay, my plan will work. But 2 hours from now, when it's actually flying this, and now that yellow red area is now right over your line. Okay, well they just need a little bit of fuel to go around the west or the east, whatever's easiest for them,
And that's up to them. We don't.
Yeah, they do that real time. And they'll talk about that with ATC. But you as a dispatcher, the only thing you're going to do is like, I probably need to give these guys some extra fuel in case they have to vector or route around some thunderstorms with ATC. And ATC will just basically say, yeah, go around the west side, it's better. Then they'll just give them a temporary little route. It'll just go around it. And it takes maybe an extra 100 pounds or 200 pounds, depending on at what point they veer off and go around it. But it's just a little bit of extra fuel, and then they meet back up with the regular route. And yeah, that's not something the dispatcher plans because it's not something we can't predict that.
So,
The only thing we can predict is that they'll probably have to do some of that to an extent, and here's some extra fuel in case you do.
so is that like, if you didn't have that MEL and you could just send that, is this like 1,000 pounds of contingency fuel, or is this
Yeah, so
3,000, is this 500?
yeah, I mean, I'd probably put on like 15 minutes extra. So that we look at it in terms of minutes normally when we're thinking in dispatch. Like, okay, well, if they got a route around, let's say that they have to take a 5-minute detour to go around a thunderstorm. Well, let's say they have to do it 2 or 3 times. Okay, well, there's 15 minutes of fuel. On a SkyWest flight, our standard fuel, which we don't do it in this class, but SkyWest, when they plan a flight, they have that 45-minute reserve, and then they always have 15 minutes of contingency. It's just part of the normal fuel. So they already have 15 minutes of extra fuel on even, a flight that has no weather. It's just standard. That SkyWest policy always has 15 minutes, unless the dispatcher wants to add more. So you're already thinking, okay, well, they already have their standard 15. That's what we call it. And then do I need more than that? That's the only question. And so, the contingency fuel is for this type of a situation. Then that other fuel that we've talked about a little bit is hold fuel. Okay? Hold fuel is for once they arrive, once they get to an airport, if they expect to have to hold and have to wait for traffic or things like that, or if something changes, it's normally more of an ATC perspective that they would have to use hold fuel for rather than a weather perspective. Weather is more driven on the contingency fuel, but the difference between those two and the reason why they exist in separate categories is because if you're a dispatcher and you say, I'm going to plan 30 minutes of contingency fuel, the pilot does not have to take that fuel with him. It does not. If you remember when we were talking about Minto, when we talked about Minto the other day, Minto is a legal term for a pilot dispatcher perspective. Minto, whatever the Minto is, has to be on board. Otherwise, the flight is not legal. Okay? If you add 30 minutes of, let's say you have a flight that the Minto is 2 hours and 10 minutes. But let's say you have 30 minutes of contingency fuel. So technically there's 2 hours and 40 minutes of fuel, but only 2 hours and 10 minutes is Minto. So in order for the flight to be legal, it only has to have the 210. Okay? So if you reclassify that fuel as hold fuel actually is part of Minto. So that's what a lot of people always ask, well, what's the difference between contingency fuel and hold fuel? Well, hold fuel is mandatory. If the dispatcher classifies it as hold fuel, it has to be on the plane in order for the flight to be legal. And if it's not hold fuel, then it doesn't have to be on there.
Why would a pilot
not want to take it?
Yeah.
It's very rare. But
They'll even add it on their own.
Yeah.
That's more common than not.
Okay.
Yeah.
I can't remember the last time I took a flight and they did not just add on. Or they'll look this up current, the dispatch, the release has been up for, prior, has been worked on. They'll look it up real time and be like,
well, we need more than that.
Across there, we'll be watching them all day. And throw an extra 500 on.
Yeah. Okay. Yeah, that's very common. The captain, he's anything more than. He's supposed to call the dispatcher for anything more than 300 pounds, more or less. Now, you do, believe it or not, there are some pilots that go less. They don't. The plane, usually once the crew arrives at the plane, it usually is already fueled. Unless they're doing a turn and they were already on the plane coming in and going back out. But most likely, most situations, by the time the crew actually gets to the plane, it's usually already fueled. So they're usually going with what the dispatcher says, because at that point it's like, if I want to add on another 500, then the fueler, you got to call the fueler back out to the plane in order to do that. So they usually will go with whatever you have. The only times where they'll usually add it is if they're there with the fueler real time, they'll be like, just bump it up to 8,200 instead of 7,700, you know? So that's when you see a lot of what she's talking about. But they're supposed to call normally and say, hey, I want to throw on an extra 500 pounds.
And then do we have to change our relief?
No, you don't. You don't, because he actually does the manifest.
Oh,
So,
right.
yeah, so in here we do the weight and balance manifest, but in real life, the pilots do the manifest, because we don't have the real numbers for the flight. So we have the passenger number, and then we just mesh together some averages and just do it that way. But anyway, so going back to this, that's kind of what we're looking at and seeing for this flight. This other weather chart here is just your convective signet charts. And so it's looking at that same weather. It's just now looking at it from a convective signet standpoint, which we couldn't see before. But this kind of helps a little bit more because it kind of gets rid of some of the green. Because remember, this area right here was kind of full. Anyway, so here it kind of just gives you a better idea about how your route's going to work. You're going to stay out of the convective signets. So you got to route far enough west to not cross through this convective signet, and then back up and around and into Helena. Any questions so far? Okay. So
I guess the convective signet is labeled to the point where you can obviously say, here's where the convective signet ends, so go all the way out to Boise.
Yeah, the convective signet, you'll see it visually like we just did, but you'll also see it textually as well. So if I come in here, you can see once we get under the signet, so this is the Salt Lake area, but if you look in the Helena area, so right here under signets, you'll see them right here. So there's that 11 west, and then it tells you the exact boundary, so you'll know that it's not over Helena or touching Helena.
Which I guess you would just kind of overlay on.
Yeah.
Do your best to overlay it, like if you're doing this on the paper chart, you just, I guess.
That's technically what. It's technically what this chart's for. That's another use for this chart. If you wanted to draw in the convective signet based on what it's saying on the text, you could draw it in right on this. So it's just another use if you wanted to use it right there. That's where you could draw it in.
I guess I guess what I'm trying to get is, are the corners of convective signets labeled as in over town A VOR? And then from town A VOR 360 radial, town B VOR, back up to yada yada intersection, and then back to town A VOR. So
we'll just read it right here. Convective signet 11 west. So if you want to know which one this is talking about, it's this one right here. This one that's closest to Helena. So that's 11 west. And that's how you can see, which one to label them like that. So 11W. Okay, going back into this. Go back down to those signets. And then right here, it says convective signet 11W. Valid until 2055 Zulu. And then this is the boundary right here. From 30, so that's 30 nautical miles southeast of Great Falls to 20 miles south of Billings, 40 miles east-southeast of Dillon to 30 nautical miles north of LKT, I'm not sure we're down back to Great Falls. So it usually will always connect back. So you can see that it starts and ends with Great Falls, and it draws. It's like connecting the dots.
So it's based off of airports or VORs.
VORs, airports, yeah. Yeah. So
That's just what I want to know. Like, it's not just going to say northern Montana or southern Montana.
yeah. So that's the thing about these. This. So if you're looking at this, when it gives you those points, that's another useful part of this map, is that when drawing convective sigmets, it only uses the ones that it listed here. So it's not going to list one that's not on this.
Okay, so it won't list.
Yeah, that's so this map is good for winds aloft stations, and they also use it when they do boundaries of sigmets. So you'll know, so the Great Falls, so right here, let me zoom in a little bit further. And like I said, don't start worrying that you're going to actually have to do this on a practical, because you're not. I mean, it's, you know, I can see a lot of people probably like, oh crap, am I going to have to like read these boundaries and map out a thing? You're not going to have to do this, you know, on your FA practical, but it's obviously good information to know. So, you know, you can actually map it out right here. So it says 30 miles. So 30 southeast of Great Falls to 20 miles south of Billings to 40 miles east southeast of Dillon. So based on that, you can just map it out. Oops. On this. So basically goes, it's like over here, 30 miles to 20 miles southeast here to 40 miles southeast. So it's kind of like a triangle, like right here. Anyway. Let's go back to this. Okay, as far as other considerations for this, you know, we want to make sure that there's no thunderstorms going on in Salt Lake. So you just start going through it like normal at this point. Start looking at the rest of your weather. Salt Lake, as far as taking off, I don't see thunderstorms anywhere in this METAR. And another key thing about this is I don't see thunderstorms anywhere in Salt Lake's forecast. So that's good to know as far as this MEL goes, that you're not seeing thunderstorms anywhere here or here, but especially in the METAR, you know, from where you're taking off. So it doesn't need a takeoff alternate. So everything else is good. Wind 320 at 4. Anyway, so we'll look at some of that other stuff in a minute, but let's just fast forward down to Helena and take a look at what their forecast is showing. So if we go back for a second here and look, we're estimated time of departure of 2200 Z. So 2200 Z out of Salt Lake. Start looking at Helena's weather here. Well, this line begins at 000 Z. So if we're leaving Salt Lake at 2200, this would basically be 2 hours after we leave Salt Lake. Okay? Starting with this one. So we know for sure that, you know, these two lines are potentially going to be affecting our time of arrival. So if we look at this and let's say that we're arriving in this line here. Well, once again, we don't know our ETA yet. We haven't figured that out. We got to go build a route and figure all that stuff out. But if it is in this one, we can definitely see that we've got a problem here. 1 mile, fog, overcast 1,100 feet. Should be glaringly obvious that we need an alternate. Okay? And if our ETA is in this line, what's the problem? Which would make what? What does that do to us?
Not legal.
Not legal. Yeah. So if our ETA is anytime after 0Z, if it falls after 0Z and between 7Z, so this is a 7-hour span right here. So if we're arriving after 0Z, then this flight is not legal to land in Helena until after 7Z. So that would be at least a 7-hour delay at that point. Okay? And then it gets good again. So, a lot to consider here. We need to make sure this flight's going to get to Helena before 0Z if it's going to go at all. Okay? And we've got this weird route to build still that's going to definitely make it longer than a normal Salt Lake Helena flight. Okay.
What's our ETA?
2,200. So we've got exactly 2 hours from ETD to take off, fly, land in Helena. As long as we can, from a legal standpoint, okay, now it doesn't necessarily mean that it makes sense as far as what will actually happen or what you would really want to do in real life. But legality speaking, from the FAR standpoint, as long as this flight arrives in Helena 23:59 Zulu or earlier, it's legal. Okay, 1 minute before that changes. And I know that all of a sudden at 1 minute, you're not just going to have 3 miles and heavy rain and thunderstorms just appear, you know. But from a legal standpoint, it's legal. Okay. All you care about in this case is the ETA. Now for your alternate, obviously you're doing the 1, 2, 3 rule. We know we need an alternate. Even if our ETA is after 0Z, even if it's not legal, it would still need an alternate, okay? Because your hour before is going to still go back into this. Okay, so we know this flight needs an alternate. We know that if it doesn't arrive before 23:59 Zulu, that we're toast. This is not legal to even send without a 7-8 hour delay, okay? So that's what should be going through the head right now. Now, looking at this 1 mile overcast 1,100, we also are going to have to compare that to what our landing minimums are. Okay, so it seems like a lot because we're really looking at everything and speculating on everything. But even once you start doing a plan like this, even if this was your final and your practical, you would still blow right through it normally. A lot of times the restrictions make it easier. It makes things more cut and dry. Sometimes it helps not having to take anything else into consideration because you have the restriction, you know. Like the flight level restriction in this case, we know that, you know, we're not going to be anything higher than 320. So anyway, let's go figure out a route. The reason why I'm going to sometimes the steps will change a little bit based on what your restrictions are. Because if you know that you have a restriction, like in this case, if we know that we got to be in Helena before 23:59 Zulu, it's best to just hurry and go build your route and look at it and figure out if it even is plausible. Because if that's not going to work, then the rest of the garbage in here, like reading through NOTAMs and all that stuff, doesn't even matter, right? So that's kind of where sometimes you're going to have to real time figure out, well, what's the most important thing for me to figure out first? And that's going to be once you figured out that, okay, at 0Z in Helena, I've got 3 miles, heavy rain and thunderstorms. I've got to arrive before that per my MEL. So I need to find out if that's even a possibility or not before you start caring about NOTAMs and, you know, taxiways and aprons and all that garbage. Okay, so let's go and look at the route possibilities. So we want to go, obviously, northwest out of Salt Lake City. If anybody remembers any of our route building with Salt Lake City. So a lot of times, sometimes when your previous routes are going to help you a little bit, because the SIDS and stars out of Salt Lake, like the SIDS, we know already from the previous routes that there is not a SID out of Salt Lake City to the northwest that we can use. Okay, so we know that we're going to need to go straight to the Salt Lake or to the Wasatch VOR. Not necessarily remember the VOR that you're going to go to, but maybe just that when we did that Salt Lake Seattle plan, we didn't use a SID. So that's because there's not a non-RNAV SID in the northwest quadrant that we can use. So you may remember that, you may not. But either way, you're going to figure that out, right? So from the route perspective, I already know that we're not going to use a SID. So let's clear this out. Let's go ahead and put all this in here. So that's our straight line if we wanted to fly it. Now, sometimes it's nice, when you type this in initially, sometimes you might want to hurry and write down that little heading right there, because remember, you end up using that later. So if you don't write it down right now, then sometimes you're going to have to blank out your route and put it back in later to figure out. So if you're using that and you've got your stuff divided up, remember, that's one of the things you need on your simplified fuel is the total average heading. So if you want to jot it down now, great. The other thing that this also helps with is figuring out the flight level. What I mean by that is that in a very north-south flight like this, some of them are easy to figure out. Like that Denver to LA is going west. Okay, that's going to be on an even flight level. But what about these that are like almost straight up and down? Okay, the key factor in this is going to be, do I land east or west of where I began? And in this case, you can tell just by your heading. It's just barely west. Just barely west, because you're flying at 349. Now, if you were flying 360, then this one would throw everyone for a loop, because we could really pick even or odd technically, because it's going to be the exact same. But if this is 359 or less, then it's going to be an even flight level, and if it's anything starting with a 0, it's going to be at an odd flight level. Okay, so right here it's 349. That means we know it's going to be even. So when we go back, so that means we can go all the way up to that 320. So two things you just figured out with that real quick is that average heading, and then you know that it's going to be 320 now. Okay.
Where we're going to be using charts, that won't really help us, right? So we can't
Well, no, because if you have that, that's where I was showing you how to use that ruler thing and just set it on there, and you can see.
We have to borrow that from you when we go to
That'll be there.
Okay.
All of that stuff will be there. Okay. So on this one, that Wasatch VOR, so here's the Salt Lake Airport. Actually, sorry, that's Salt Lake Airport. It's pretty much over the VOR. So we're going to go Salt Lake direct to Wasatch, which is right there. And then we can just start cruising to the northwest, like on this J12. I don't know exactly where we're going to go yet, but if we go and just start kind of examining our kind of just looking to where, so we see Twin Falls, so Boise is obviously in the clear over here, and then kind of just going straight north of Boise and then around is kind of what we're looking to do here. So if I already took it to Wasatch, and then if I just take it to Boise, can just plan Boise VOR just like that. Now, going north, MYL. So let's figure out where MYL is. So if there's ever something that's not showing up, like even go, even check the low chart. You can also, if you're ever looking for something that you can't find, you can just come up here and just type in MYL. And it'll actually show you right where it's at. So that it puts the cursor right over it. So it's this McCall Airport right there. So it didn't show that VOR on there. I don't think it's so. Donnelly should be on the high VOR, but yeah. So the problem is the Boise VOR doesn't connect with the Donnelly VOR on a jet route. However, it does on a Victor route. So if we take that over now, just plan that VOR. Back, take a look at our map again. So from here, if we went up to like Missoula, that's what MSO is right there. Come back. So I'm just trying to really just follow the points on the map there.
What if you shot straight to Helena from there? Because you'd kind of be right on the outskirts of that.
Yeah, you could. Problem is, can you get there from?
Is it routing it backwards?
Is this you're saying?
Well, because in your box it says Donnelly and the Victor route before Boise. And
yeah, it might be.
You don't have your destination is that way.
Yeah, we'll fix that. It's probably, yeah, it thinks that all this stuff is before that. So, but we'll fix that in a minute. So let's go back. So from Donnelly, we need to go to Missoula. And I'm just looking here. So there's not a jet route, obviously, that goes to Missoula. Actually, sorry. Missoula, right? Missoula's over here. So just looking at this. So it doesn't, there's no real route that we can take. There's not a Victor route or a jet route that goes there. So we're going to actually have to just keep our path going to the north.
Can you not go just a tiny bit to the right of that one that we're on this Victor route, and then up to Helena?
Like right here?
Yeah.
Let's see. So that's the Salmon VOR, my favorite VOR. Well, let's take a look. That Salmon VOR is going to be right there. So no, probably not. That would be the determining factor there, though. I mean, we would try to, but you just have to compare it with this, and you probably want to steer it away from it. So instead of that, we'll drag it over here to the Nez Perce VOR. And then from there, we'll take it up to Missoula. And then from Missoula, it can go right into Helena. So let me get rid of that part.
Also missing your destination.
Yeah.
Okay.
Up at the top there.
Yeah, I'm just gonna erase it like that. Why did it get rid of that? Anyway, this went to Wasatch, Boise, DNJ. Can't remember that other one. Oh, it's MQG. Yeah, so I didn't put the Victor routes in there, but we would need to technically write those in.
Like 2 hours and 35 minutes. That's an hour and 10.
So that's pretty much the minimum that you're gonna probably get away with as far as the route goes. You know, we still got to stay on airways. We got to route around this weather. So that's pretty much the best we'll really be able to do is get it. So we're looking at 633.3 miles. So
For some crazy tailwind.
yeah, once it's all said and done, for sure.
So would you even continue knowing that it's going to be 5 hours?
Oh, that's
Well, we don't use that. Remember,
Oh,
do not use that ETE. So we need to go. If it's 633.3, divide that by 400 for our initial, right?
Right.
So we're looking at 1.58 hours.
Yeah. Easy.
Initial, I mean that's yeah, but you're right. I mean we still gotta look at the winds. Well, not really. It's 1.58, so that's more like an hour 30, hour 35.
Oh.
Got to do the taxi out though. So yeah, because remember 0.58. This is 0.58 of 100, not 60. So whatever. So you got to take your 60 and times it by the 0.58. So 34.8. So an hour and 35 minutes based on the initial. But it's technically going to be 10 minutes after that though, because of your taxi out. So your ETD is 2200. 10-minute taxi out, so 2210 plus an hour 35. So at that point, you're 2345 is where we're sitting right now.
We always plan at 400.
Just on the initial. Just on the initial. No, because the reason why you've seen the true airspeeds, they're more like 450, 460. The reason why we're doing 400 is because it brings the average down in case we do have tailwinds, or headwinds, I should say in this case. So it's compensating for that, because if we put in 460 but then have a 50 knot headwind, then it's going to bring it down anyway. So that's why we use 400 though. Okay, so the initially it's legal so far. As far as that route goes, it is. It's awesome. As far as the way this route goes, if we're writing it down, it's Salt Lake City to the Wasatch VOR, then what's going to be that route? J12 to Boise. See, there's another thing, like why we actually write in the route, because you see how that's not perfectly on J12. There's a little bit of a misalignment. Anyway, and then from there, you're on Victor 253. We got to just figure out how far we follow Victor 253. So we follow Victor 253 through Donnelly all the way to Nez Perce. So Victor 253 to the MQG, and then Victor 187 to Missoula, and then Victor 2 to the capital VOR CVP. And then, does anybody remember if there's any stars to Helena?
I think there was.
I think our route to Helena was,
We did a sit.
well, we went, Sacramento to Helena was the route that we did a week or two ago. We can just look right here. Yeah, there's only departure procedures. There's not any arrivals. So, yeah, it doesn't have any stars. So we're just going to go capital VOR and then to the Helena airport.
Couldn't you find an instrument approach and then route it to the initial picture?
Not on a Not on an ATC IFR flight plan. You have to route to the VOR, to the airport, and then they're normally going to cut you short and take you to the fix. But
So you have to write in there VOR and then the airport?
No.
HLN? Oh.
No.
Sorry.
Just CVP.
Okay. With that weather chart that we were looking at, and it caused us to go to Missoula, and we were just making that tail end of it. What time was that weather chart at? Because is that current?
Which one?
The one, that one.
Yeah, this is the current view. So this is real time, as if you were.
So,
what's
and
going on
we're
right now.
planning 2 hours before our flight departs. So would we check 2 hours in the future to see where it's at?
Yeah, but the only thing we have for that is this. That's why we looked at this. But this, according to this though, it says it just gets better in 2 hours.
Right.
Or 3 hours.
And that's why I was thinking that maybe we didn't have to go to Missoula because we were just clipping the corner of us.
Yeah, I see what you're saying because based off of this, but the problem is that you have to go off of what's currently happening. So because the forecast is always just going to be speculation. I mean, it's usually very accurate speculation, but if you know it's occurring over the Salmon VOR right now, you can't expect that it for sure won't be.
Okay.
That's the problem. Is you have to go off of the most restrictive. Just in case, let's say this is wrong, but a current report is never wrong, but a forecast is wrong a lot.
Okay.
So that's where you have the issue. You have to go over the current report that you know it's happening now, and you don't know for sure that it's going to end, even though this says it is going to or should. It doesn't necessarily always is 100%.
So then the only reason why we would have this is to see if it's forecasted to get worse. It doesn't matter.
Yeah, exactly. And you'll learn that with aviation is that weather, stuff like this, only hurts us.
Okay.
Yeah, it can't, if the current condition is one thing, a forecast can only hurt us. It can never help us.
Okay.
So. Okay, so that's the route. Got that ETE figured out. Seems like it's legal. So if it's an hour and 35 minutes en route, just real quickly on your initial fuel estimate, what are you going to come up with on that?
5,500 about? 55,
Yeah, 5 plus 3.
So we know 4,000, and then so I'm just taking that 3,000, and if you want, just divide it by 60 to get it into minutes, and then just times it by the 34.8 or whatever it was. 34.8 minutes. So 1,740 plus 4,000. So yeah, 5,740. So 5,740 would be the burn. We know that this is going to need an alternate as well. The other thing is when you're considering the legal to go stuff. Let's see, where's right here? Or sorry, the legal to go. So we saw that the weather for Helena was pretty low. It was 1 mile, overcast 1100. It was the current, or sorry, what the TAF said it was going to be at that ETA. So let's do a quick glance of their NOTAMs and then check their landing minimums, because that's another thing that's going to affect whether this is legal or not. So you have obstacle, okay, Helena, aerodrome, segmented circle, not available, okay, doesn't matter, obstacle flag. So runway 523 is closed. So just remember that. Runway 9 and 27, work in progress. Okay, it's not anything restricting. It's just telling us that there's construction going on, but it's still open. Runway 5, all signs out of service, but that runway's closed anyway. Pappy's out of service, but once again, that runway's closed. So then another obstacle, crane. Let's see, another obstacle. So there's nothing other than 523 is closed, but we'll have to check to see if that's even the runway that we would be using. So other than that, there's nothing else really restrictive in there. From the FTC NOTAMs, this RNAV procedure, which we don't use, RNAV, that one we don't use, and that one we don't use. So there's no FTC NOTAMs that are restrictive for us. It's all just RNAV stuff that we don't use for our stuff. So let's go back to here, go back into the flight planning, and oops, wrong one. Let's look at Helena. So, okay, so that 523 was the one that's closed. So the one that we really use is the 927. So now just by looking at this chart again, you can tell real quickly which is going to be the end of the runway that is most likely going to have the nice instrument approach with the best landing minimums. 27, right? Because it's got the lights. 9, no lights. So let's scroll down. Let's take a look. Actually, I have them right there. So 9 and 27 tells us got the high intensity lights, the medium intensity approach light system. Okay, so it's the departure procedure. So we're now looking for runway 27 approaches here. So okay, so ILS or localizer runway 27. Okay. There was nothing noted out of service, so we know that this instrument approach is available to us. And now it just is going to depend on what our minimums are here. So right here we have, what's our ceiling? 600. And what's our visibility?
1 3/8.
1 3/8. So if we used this approach, is this legal?
No.
No, and why?
Because we have an overstrap.
Yeah, but what specific landing minimum is killing us here? The ceiling was 1100. It was the visibility. Visibility was 1 mile. This is saying we need 1 3/8. Okay, so that doesn't work. The only other thing to check here is do we have another one that might work? Okay, so this next one is ILS, also runway 27. So let's see this one. So sometimes you have two different approaches for the same ILS. One will have higher and lower minimums. A lot of it just has to do with the it's more like the fix that they're using to come in on. For our intents and purposes, nothing. I mean, if we can find one that's better, even though it's the same runway and it's also an ILS, we just use it. And as long as it has Cat C availability in it, So does this one work?
Yep.
Yeah. That's our.
Cat C again, just because that's
700.
That's what the 700 is. Yep.
Yeah.
So 200-foot ceiling, half-mile visibility. So this one is good. We know there's no NOTAMs for it. It's legal. The only other question is just making sure that the wind favors runway 27. And if it doesn't, we just have to make sure that it's not more than our max tailwind. So with the winds, we can still land on a runway if it's not a headwind. It's just that you can't land, it just can't be over a max tailwind. So in the 700, once again, turning back the clock to the systems and the capabilities, the max tailwind is 10 knots. Okay, so I don't even know if this is a tailwind, but let's go back and take a look. was. Got out of it and I can't remember which one it was. 7.6, I think. Okay. So going back to our Helena Taff. Is our wind okay?
Yes.
Yes.
It's runway 27.
It's almost a headwind.
It is a headwind.
Or like, yeah, almost direct.
It is a headwind, yep. Almost a direct hit. So we're good. 280, 10 knots, gusting to 20. So yeah, it is a
Best
headwind.
thing in the whole thing.
Yeah. Yeah, exactly. Okay, so the only other question is right here. So we know we need the alternate. We know we're still legal. Now it's just really, what's the alternate availability? So I'm just going to see here in the weather packet which ones we actually have here. So it's giving us Kalispell and Great Falls.
Where were the corners of the segment? I remember it talking about Great Falls.
Mm-hmm. Yeah, Great Falls is one. So when you go back to your map and we look at things in relation to our map here. Now let's see. We'll go back to the other one would be better. That one doesn't have it on there. Let's see. Okay, so Great Falls, if you go back to this map right here. So here's Helena. There's Great Falls to the north. And Kalispell is this one up here. So the important thing here would just be picking one that goes the most out of the way of the weather. Kalispell looks, would be the most, and then that one segment that we were reading actually has Great Falls wasn't in it, but it started at 30 miles southeast is what it was. So went around, so it's a lot closer. But if Helena's in it, Helena would be in it before Great Falls would be. But the problem is, let's say Helena did get thunderstorms. I mean, the most probable that would be avoiding thunderstorms would be Kalispell for sure. So,
Would you grab 2 alternates?
You could. The fuel just needs to go to the most distant. But what we normally do is, in dispatch, we kind of say, well, in lieu of doing 2 alternates, just do 1 good one, because if the good one is the Kalispell, you have to have fuel for the most distant one anyway. So just have it be the good one and just list 1. So, well, the air conditioning signals the end of glass, but
Yeah, it's bedtime.
yeah. The next thing that we would look at here, though, is the forecast for Kalispell and Great Falls. So that's the next step in this process, but we're done.
Will we go over this tomorrow morning? Or are we going to switch it up?
Yeah, we'll continue doing this one like in these other. I'm also going to be recording those too, so if you want to see them.
Are you gonna come to class?
I can't put this whole week up. Just come to class every single day. I need all the help I can get. So
right there, because they should do that.